Hello and welcome. My name is Vansh Yadav, and the following is a presentation as evidence regarding the completion of my final project and the attainment of a successful project outcome for the personal project 2020. The date is the 17th of February 2021, and my goal was to research into the science behind the functioning of a rocket booster and simplify its complexities by designing a comprehensive digital simulation for individuals keen to learn about astronautics. I believe I have done so successfully, and a detailed analysis regarding the success criteria being tested against the project has been attached in Appendix B1 of the personal project report. Nevertheless, that is beside the point of this screencast. I created my project in Unity 3D, a game design engine which also doubled as a 3D design engine for the simulation I was intending to create. It also comes bundled with a physics system, which will be very important concerning the physics and technical nature of my project. First off, I will I will display the project itself within the Unity 3D engine. So if we start, we greeted by some basic information about the project. However, this is the simulation itself. As you can see, we are currently looking at a variety of variables of thrust regarding a rocket and the physical concepts involved in it. We can see exhaust velocity, we can see mass flow rate, we can see exit pressure, we can see free stream pressure, and the area ratio. And in addition to that, we have some dependent variables which are being showcased on the GUI for the simulation, such as thrust, velocity, and acceleration. On the other hand, we also have propellant, a percentage indicator with propellant left, which has been extrapolated to another visual indicator. We also have the elapsed time of the simulation having begun, in addition to a digital representation of the rocket, its thrust, and a depiction, a portrayal of the fact that it is currently in space, which is important to consider when calculating specific impulse of a rocket, which differs from at sea level and in space. Regardless, this technical nature is not what I am here to explain. Other than that, in order to display these scientific concepts, two main features have been involved. First is the ability to change different variables of thrust and see their effect in real time. Such as if I currently add another zero to exhaust velocity, making it 22,000 from to 2,200, we will see thrust change, velocity change, and acceleration change, which is clearly visible. If we change the mass flow rate, we would see mass depleting faster and also thrust, velocity, and acceleration increasing. As you can see, that happened right there. We can do the same for exit pressure, free stream pressure, area ratio. Yep. But the main thing is, most people, as the goal, as you might recall, was to simplify for individuals keen to learn about astronautics. Focus on the word simplify, and in that regard, detailed, concise, and well dumbed down information regarding every variable of thrust and every variable visible on the screen have been provided. If I click thrust, you will see an explanation of thrust. It has been simple understandings have been included along with formulas, a detailed explanation which is concise. The same has been done for velocity. It's been explained. Acceleration, exhaust velocity, mass flow rate, and so on. You can also reset the simulation once the fuel ends. Let's do that for a second. Fuel just ended, and as we can see, thrust has depleted completely, acceleration has depleted because the force is no longer being applied, and acceleration and force can only exist when the forces are unbalanced. The same goes for acceleration, but velocity remains constant because velocity will not be altered in this case when a force is no longer being applied. Balanced forces, as has been stressed in our physics classes, balanced forces does not equal a lack of velocity. As we move on to the proof of the coding, etc., we can first, as there are a bunch of different scripts which you can see here. However, the main ones regarding the science itself will be I will just bring up rocket physics. Give it a second. There we go. As we can see, this is a quite detailed script, a C# script written in C#, which is the default language for Unity 3D. As we can see science being used. We can see when regarding functions, we can see the actual formulas being used, such as mass flow rate times exhaust velocity, exit pressure, friction pressure, error ratio for calculating thrust, which you will see will be parallel to the thrust equation that's been visible in the explanations in the simulation. Here we go. This, you will see the same here. Same goes for velocity. You'll see a natural logarithm being taken here, which you'll see in the same for velocity. My bad. There we go. Etc. etc. So the coding itself parallels actual physics equations, which I've understood and researched into, and so on. As there are a variety of different scripts, etc. etc. Executables for Mac OS and Windows will be provided and linked to in the appendices of the report, and a WebGL version to be used online will also be included to increase accessibility of the project. The entire project has been uploaded to GitHub, which is a code repository system where code can be published publicly. This has been done for the purpose of evidence and proving that the project was actually done and proving its authenticity, and again improving its accessibility and workability in the future as public collaboration may take place. Individuals may branch the project, individuals may fork it, they may add new suggest solutions, etc. etc. Thank you.